Hi class. So previously we have learned that there are different ways to measure the atmospheric pressure. And before that, we have seen that in a U-tube filled with certain type of liquid. Okay, so we also learned that when they are at the same level, the pressure is the same. The pressure is the same. And at this example, this diagram, we can see that between the two liquids, liquid A is stronger, or we can say is denser than liquid B, because at the same level here, they have the same pressure. Okay, P1 equals to P2. And we also can say that the liquid A is stronger than liquid B, or we know that liquid A is denser than liquid B. Why? Because it only needs this amount of A to have the similar amount of pressure at point 2. That means less A equals to a lot of B. That means A is denser than B, or let's put it in other words, if A were to fight with B, A wins because A is stronger. Now, change this into gas. Then we have gas pressure. The concept is fairly similar. Okay, let's see. If we have a manometer filled with water with open end, so this is water and this is open end, we know that the water will be at the same level. Okay, and that means at this level the pressure here is equals to here, and it is equals to the atmospheric pressure. And also if we make another line here, the pressure here is equals to the pressure here. That means it is actually ATM plus H. What happens is, what happens when we connect this end to a gas? This is what happened here. Okay, after connecting to a gas supply, you can see that the gas is no longer ATM. It has its own pressure. Let's see in this term, between the gas here from this height and this height, the gas fight with water. Who wins? The gas. Why? Because you can see that this has the same level, which means pressure at A is equals to pressure at B. From this picture also you can see that the gas was able to push this amount of water. That is why we can see that water rise above point B. The gas pushes this water, and then the water flows upwards here because the gas pushed the water. When the gas pushed the water, that means the gas is stronger. It doesn't mean that the gas is denser, but the pressure of the gas is higher than the pressure of the atmosphere. Since here is equals to here, so we actually can calculate the pressure of the gas by calculating the pressure of here plus the atmospheric pressure. So pressure at B is equals to H. Let's say this is water, so it is actually pressure at B equals to H meter of H2O plus 1 atm. So you can actually change it since 1 atm equals to 10.3 m H2O, and also you know that this amount of water is being pushed by the gas. That means the gas exceeds the atm by H, right? So plus H. Sorry, not here. So you plus H at the gas pressure. 10.3 plus H. Let's see. H is 30 cm. So you plus 30 divided by 100 because cm needs to change to meter. And then you get the answer 10.3 plus 0.3 equals to 10.6 meter H2O. This is the pressure of the gas if we say that H is equals to 30 cm. Basically what I have just said is what is displayed here. Okay, A and B, same level, same pressure. Let's see next example. Okay, before we see the example, let me give you another situation. Let's see. This is X, gas X. And this is mercury. Based on this diagram, do you know what is the pressure of the gas? Can you tell me what is the pressure of the gas? The pressure of the gas, pressure of gas X is equals to the pressure of the atmosphere. Why? As you can see here, they are both at the same level. That means pressure here equals to pressure here. If here we have the atmosphere, here we have gas X. So the pressure of gas X is actually equals to the pressure of the atmosphere. Okay? Another example. Let's see. This is gas Y. This is the atmosphere. Based on this diagram, can you tell me which one is stronger? The gas or the mercury here? The gas. Yes. Why? Because you can see that this level has the same pressure. Let's say this is A and this is B. So pressure at A equals to pressure at B. And you also can see that the gas is strong enough that it push this amount of mercury. The gas is strong, it push this amount of mercury above. That means the gas pressure Y is greater than pressure of the mercury, or is actually the pressure of the atmosphere. So how much does the gas stronger than the ATM? Let's see, this is 6 mmHg, or you can just say it's 6 mm. So you know that the pressure Y greater than pressure ATM. How much? It is more than 6 mmHg. So to calculate the pressure of gas Y, we simply put pressure ATM plus height. Why? Because this is same thing as this. Since we put the pressure of the ATM in mercury, so we can just add the height. So 760 mmHg plus 6 mmHg. That means the pressure of gas Y exceeds the atmospheric pressure by 6 mmHg. Okay? Another example. Let's see. We have this manometer. This is mercury. This is the height, 12 mm. This is gas, R. So based on this, can you tell me which gas is stronger, atmospheric pressure or the gas R? Gas R. Yes, gas R is stronger. Why? Because gas R can push the mercury for this height. The gas R push mercury until the mercury exceeds by 12 mm. So it shows that gas R is stronger than ATM. We know that ATM here is equals to 76 mmHg. So since gas R is stronger than ATM, that means ATM plus the height. And by this, we can get the pressure of gas R. This is the pressure of gas R. Another example. This is gas X. This is atmosphere. This is the mercury. Can you tell me between gas X and mercury, gas X and ATM, which one is stronger? Gas X or the atmospheric pressure? Yes, atmospheric pressure is stronger. Why? Because you can see that ATM pushes the mercury by 5 millimeter compared to gas X. So ATM is stronger than gas X. When ATM is stronger than gas X, we have to add. We have to minus this value to get the pressure of gas X. We know that ATM equals to 76 mmHg. And let's say pressure of gas X is Px. So ATM is greater by 5 mm than Px. That means pressure of the ATM equals to pressure of gas X plus 5, right? So to calculate the pressure of gas X, we have to minus pressure of ATM minus the 5 or the height, which equals to 760 mm minus 5 mmHg. So you get the answer 755 mmHg. This is the pressure for gas X. Can you see the difference here? Let's see another thing. Okay, it's kind of the same thing. This is mercury. This is 20 mm. So this is gas Q. Can you tell me between gas Q and the atmosphere, which one is stronger? Gas Q, right? Because gas Q pushes the mercury by 20 millimeter. That means gas Q, pressure of gas Q equals to pressure of the ATM plus 20, because pressure of gas Q greater than pressure of ATM. What if we change it the other way around? Let's see. If it goes like this. This is gas T. This is ATM. and this is the height. And still we're using mercury. Between these two, between gas T and ATM, which one is stronger? Yes, ATM is stronger. Why? Because ATM push 18 mm of mercury upwards. So when ATM is stronger, that means the pressure here equals to ATM, while here equals to pressure of gas T plus height, because it has height here. So we can rewrite PATM equals to pressure of gas T plus height. So PATM is 760 equals to pressure of gas T plus height. Height is 18. So pressure of gas T equals to 760 minus 18. You get 742 mmHg. Is it clear? I think it is. Okay, let's see next example. This is the thing that I've been telling you. So, here's a mercury manometer. What is the pressure of the compressed gas in cmHg? So, you can just look at the figure. Between gas and atmosphere, which one is stronger? Gas. Why? Because it pushed 40 cm of mercury. So we know that to calculate the pressure of gas, it is actually equals to pressure of the ATM plus height. So pressure of ATM is 760 mmHg, also equal to 76 cmHg. So simply plus the height, 40. So you get 40 plus 76. This is your answer for the pressure of gas. So calculate the pressure in PA. Use the formula H rho G. We know the height. We know the density of the mercury. We also know the gravitational acceleration. So substitute everything and you get the final answer. What about the question C? Will your answers in A and B change if the glass tube of the manometer has a larger diameter? The answer is no. Why? Does not depend on the surface area. Remember, pressure in liquid equals to H rho G. It only depends on height. Alright? You get this? Let's see the next example. The same thing. We have studied this also. Question A, what is the difference between air pressure? So the difference is simply the value of H. So the answer is 25 cmHg. What about question B? If the ATM is 76, if the ATM is 75, it means here is 75. What is the air pressure in the pipe in Pascal? So we know that air pressure in the pipe is stronger than ATM because it pushed 25 here. It pushed the mercury upwards. That means pressure of air greater than pressure of ATM. It is greater by what value? So just add 76 plus 25. So the pressure of air is equals to 100 cmHg. The question asks in Pascal. So what you need to do is convert using the formula we have been using, H rho G. So change to meter, multiply with density of the mercury, and multiply with gravity, and you get your final answer. With that, we have concluded our chapter 2.3. To show that you actually understand what is being taught, answer all these questions and submit in your Microsoft Teams as assignment. Thank you. Bye.